Okay, we're going to look at mostly sets in this video with unions and intersections. However, before we do, let's talk briefly about the real numbers and how they are organized or how they are categorized. They can be broken up into sets themselves. So we have the natural numbers, which we use N to represent the whole numbers, which we use W. Integer, we use Z. The rational numbers, we use Q. And then all of these are real, including the irrational numbers, which we use I. The natural numbers, those are the ones you could like see naturally. And they start at 1, if you think about it that way. So 1, 2, 3, only positive numbers with no decimals. Whole numbers include 0. So now we include 0 and then all of the natural numbers. So we can say natural numbers are a subset of the whole numbers. If a number is whole, it is also natural. It's kind of work your way down into the circles or ovals there. Integers, they include the whole numbers, the natural numbers, but also negative numbers. So we'll put just -2, -1, and also 0, 1, 2, 3. Still no decimals. And the rational numbers Q, they contain everything that can be written as a fraction. This includes decimals that are repeating. This includes decimals that stop. So like 3/2, 1.7, 1.333 repeating. All of these are rational numbers. The irrational numbers are their own set. So they do not include the rational numbers, the integer, the whole, or the natural. The irrational numbers kind of are by themselves. These are numbers that their decimals go on forever, but they do not repeat. So something like the square root of 2, if you put that in your calculator, you'll get a decimal that just goes on forever. So that, or a very popular one is pi, as that 3.14 just keeps going and going and going. E is another irrational number. So these are irrational numbers that cannot be written as a fraction. Okay, so this question here says, to which subsets of the real numbers does each number belong? So pause this video, try to answer this on your own, and then see how you did. And okay, I'm going to interrupt myself real quick to make a quick correction. I had some thoughts backwards in my head. So when we look at 0, which subset does that belong to? 0 is a whole number, but it's not a natural number, but it is also an integer. 0 is also a rational number. And then even a real number, which we already know it's a subset of the real number. 5.67 can be written as a fraction. It's not an integer, but it is a rational number and a real number. 5.6 repeating, because it repeats, it can be written as a fraction. It's like, or -5.6. It's -5 2/3. And so that is rational, but it's not an integer. It's not whole or natural. And then on D, square root of 7 is irrational. It's that repeating decimal without a pattern. It can't be written as a fraction. So it is irrational and real. Okay, so let's continue this discussion on sets and subsets. So with subsets versus elements, so how do you know which one to use? So when comparing two sets, you're going to use a this is for notation. It's a little unclear. So when comparing two sets, the notation you'll use are like an equal sign or not equal to. And when comparing a member or an element and a set, you'll use the element of or not an element of. And so this is just kind of clear up notation. So we could say like set A is equal to set B. But we wouldn't say like, we wouldn't say A is equal to 2 or 2 is equal to A. If it belongs to set A, we would say A is an element of, whoops, that's not right. We would say 3 is an element of A for some of the notation stuff. Okay, so here, these are true or false questions. So there's some examples. We just want to know if these are true or false. And so here you're given A, the set is an odd counting number smaller than 10. If you're given these in words, especially if there's not that many values, probably a good idea to write them out. So an odd counting number smaller than 10 would be 1, 3, 5, 7, and 9. So counting number also is another way to say it, like the natural numbers. So it doesn't include negative. And then, okay, so now we're ready. So A is A 1, 3, 7, or 1, 3, 5, 7, 9. I should use my brackets there. And then this 3 dots mean they go on forever. Does it continue on? And this is false because it's got to be smaller than 10, so it will not continue on. This says 4 is not an element of B. So find B, and sure enough, there's 4. So 4 is an element of B. This is also false. This one says B is not equal to C. And that's true because they're not the exact same set. C has 1, B does not, and that's enough to say they're not equal. So this is true. And this says C is a subset of A. And so are all of these numbers in A? And that's false. 2 is not in A, so this is false. And this symbol, I'll write this a little bigger. This symbol means subset. So let's see, it looks like a sideways U with a line underneath it. It's a subset of A. So let's look at another definition. A and B are sets. If A and B are sets, and A and B is A union B. What this means is the set of elements of A or B, or it means all the elements in both A or B. The notation is this big, it's a union symbol, or a cup. It looks like a big U for union, which is nice to think about as you memorize. But that means to join them together. So it means one or the other or both. If this were A and this were B, the union would be in this Venn diagram. It would mean all of this. So it's what they, it's just putting them together, taking A, taking B, putting them together in one set. The intersection. So an intersection, A intersect B, we write as A with that upside down union. It's the cap B, and it's the set of elements of A and B. So it's what they have in common. We'll say what they share. We have this word and that we use, or it's in both. And if this were the diagram, then it would be shaded in the middle. An empty set, we use this notation, the circle with a line through it, you probably have seen it before, or might have seen it before with using no solution. It means there's no solutions in the set. That's why we use that. And it's a set with no elements. So it's not 0. It's nothing, which is confusing, but it's just the empty set. There's nothing in there. So kind of this last note here on this page, just to clarify, if A and B, or A intersect B, is empty, meaning there's nothing in common, then we write A intersect B is equal to the empty set. Okay, so, and then as I mentioned, the empty set does not mean that, does not mean 0. So 0 is not equal to the empty set, because 0 is a number, or 0 is an element. So if 0 is in the set, then the set is no longer empty. It has something in there. It just happens to be 0, which we often equate with nothing. And so that's pretty confusing, but just keep that in mind. The empty set and 0 are not the same thing. Okay, so there's a handful of examples, and I'm going to run through these kind of quickly. So make sure you pause the video and try these on your own as you get to the question. Get that out of the way. And sometimes it's very helpful to draw pictures as you work through these and list out the sets. Use different colors to kind of keep track of what is what. Helps quite a bit too. Okay, so on A, this is D intersect F. So this is what they share or have in common. And so D and F, they both have a 3, because this is 1, 2, and so this dot dot means the pattern continues. So this F is 1, 2, 3, 5. Let's write that out actually. So D is 3, 5, 7, and then F is 1, 2, 3, 4, 5. So their intersection would be 3 and 5. They both have 3. They both have 5. So D intersect F is 3 and 5. And that's what we're looking for. That's the answer. Sometimes when you're seeing the set stuff for the first time, it's a little confusing to think, okay, well, what's the answer? What are they asking for? And that's it. So there's not a lot of steps, which sometimes gets confused with it being like, oh, there's not a lot of steps. It must be an easy question. That's not true. These questions are actually very difficult. And one of the reasons they're difficult is because there's not a lot of steps. If you're not really sure how to do it, you can't like look and see like step 1, step 2. Oh, I got confused on step 3. This is where I'm messed up. It's like you got to go back to the definitions, work through your thinking, and figure out where you're confused. But these are pretty tough questions. Okay, so if you have like parentheses like this, it's like order of operations. Find what's in the parentheses first. So let's find F intersect E. So F and E, what do they have in common? Well, they both have a 2 and they both have a 4. So this is going to be the set 2, 4. And now we're going to union that with D. And so we have D union F intersect E. This is just everything that they have. We'll put that on the next line here. So D is 3, 5, 7. So 3, and then I'm going to combine that with 2. Whoops. Let's change the order there. 2, 3, 4, 5, and 7 would be the union of those two sets. And then C, we're going to find these two unions and then see what they have in common. And so D union F . would be all of these things, and we won't write, well, I guess we will write that. So 1, 3, it'd be 1, 2, 3, 4, 5, and then 7. And then D union E would be 2, 4, 6, 8, and then 3, 5, 7. So 2, 3, 4, 5, 6, 7, and 8. And then we'll put them together all over here, or not put them together, but what do they have in common? So they both have they have this 2, 3, 4, and 5. 2, 3, 4, and 5, and then they both have a 7. So this would be 2, 3, 4, 5, and 7. Okay, now you want to fill in the blank, and there could be more than one answer. So this is kind of just a note over here. Remember, element and not an element of is for when you compare an element. Since they're all numbers, we'll say this: a number and set, or number to set. And this is a set to set. So subset, not subset. You have to be talking about two sets. Okay, so 5, what about 5 and E union F? Well, E union F would be putting these together, and so 5 would be included if you combine those. So 5 is an element of E union F. 3 is not in E something F. So I want to get 3 out of there. So 3 is not an E, 3 is an F. So if I intersect those, if I see what's in common, they would not have a 3 in it. So 3 is not in the intersection. G, I want to know if G, since this is a set and then another set, I'm looking at subset or not a subset. So D intersect F. Let's figure out what that is. That's what they have in common. And 3, 5, 7, and then 2, 4, 6, 8. That is just empty. Oh, I was looking at the wrong one. Sorry. 1, 2, 3, 4, 5. So they have a 3 and a 5. And G, the set is 3, 5. So they are equal to each other. You could also say they're a subset. Technically, that's true, but a better answer would be equal. And then D intersect G, what they have in common, how's that compared to D? So that's just 3 and 5 again. And then this is a subset of D. And you could know that because D is the intersection, then it's going to be a subset of D here. Okay, and then last couple examples here just about the empty set. So take a minute, pause the video, try these. So A union the empty set, this is false. It's not equal to an empty set because it will include all of A. A with nothing gives you A. Is D a subset of the empty set? This is also false. Because D has an element in it, it can't be, if you will, like smaller or fit inside of the empty set. However, the empty set is always, and that's that note, a subset of another set. So note about empty set and subsets, the empty set is always a subset. Because a set can always contains nothing, if you will. Okay, this is a lot to process, so I would rewatch this if you need to, ask questions, find some more information on this, and make sure you get some practice.
Okay, I'm going to interrupt myself real quick to make a quick correction. I had some thoughts backwards in my head. So when we look at 0, which subset does it that belong to? 0 is a whole number, but it's not a natural number, but it is also an integer. 0 is also a rational number. And then even a real number, which we already know it's a subset of the real number. 5.67 can be written as a fraction. It's not an integer, but it is a rational number and a real number. 5.6 repeating, because it repeats, it can be written as a fraction. It's like, or negative 5.6. It's negative 5 2/3. And so that is rational, but it's not an integer. It's not whole or natural. And then on D, square root of 7 is irrational. It's that repeating decimal without a pattern. It can't be written as a fraction. So it is irrational and real.